Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to write linear equations. So the instructions are as follows. We have to write the equation of the line with the given information in slope-intercept form and graph. And after graphing, we're to label the intercept and rate of change. So the first question, number one, let's say the slope of the line is 1/5 and the y-intercept is -3. So the formula we're going to be using here is the slope-intercept form of the equation of a line because we already provided with the slope and the intercept, okay? So the slope-intercept form is y equals mx plus b. We just need to determine m and b, substitute it into this equation, and then we are done. All right, let's start by finding m. The slope is the same thing as m, and that's 1/5. And one thing you want to note is that the slope is also the rate of change. All right. If you're asked to find the rate of change of a line, you're being asked to find the slope. All right. Y-intercept is b. All right. That's where you start your graph on the y-axis. So your y-intercept is -3. So the equation of the line is going to be y equals m, which is 1/5, x plus -3. That's your b, okay? And then we can simplify it into y equals 1/5 x minus 3. Now this is the slope-intercept form of the equation of a line, okay? Slope-intercept form. This is the form that we're asked to generate. Okay, so the next part involves graphing the line and labeling the intercept and the rate of change. Okay, so if you want to graph the line, we just simply need the slope, which is 1/5. For graphing purposes, we just need to indicate the rise and the run. So you're going to rise 1 and run 5. Remember, rise is either up or down. Okay, you can either rise or fall, but you always run from left to right. And then your y-intercept b, where you're going to start, is -3 on the y-axis. That's your beginning. Okay, let's go ahead and graph the line. Okay, so since my y-intercept is kind of big, I'm just going to shift my x-axis upwards to compensate for its size. Okay, so let's graph the y-intercept, -1, -2, and -3. All right, so there goes your y-intercept. Now we need another point to define our line. So we're going to use the slope to find the next point, okay? So we're going to rise 1 and then run 1, 2, 3, 4, 5. Bam, there goes the second point. And let's go ahead and draw the graph, something like this. All right, so since it's a line, it goes infinitely in both directions. Okay, so just to label, right here, this is our y-intercept, okay? Y-intercept. And then this right here is our rate of change. You rise 1 and run 5. All right, so let's just color code that. So our rate of change is the same thing as the slope. So what we're doing is we're rising 1 and running 5. So m equals 1/5 is our rate of change, also known as the slope. All right, let's take a look at question number 2. For question 2, we have 3x plus 2y equals 8. Now, for your information, this is actually a form of the equation of a line. This is known as the standard form, okay? This is a standard form of a linear equation. We are asked to write it in slope-intercept form, which is y equals mx plus b. This is our entire target. So what we're going to do is get y isolated because that's the form here. All right. We can accomplish that with two steps. Subtract 3x divided by 2. Let's go ahead and do that. Subtract 3x from both sides. And then that yields 2y equals negative 3x plus 8. And then to get y fully isolated, divide every single term by 2. All right, so that yields y equals negative 3 over 2x plus 4. Okay, so that is the slope-intercept form of the equation of a line with the standard form. All right, so let's go ahead and indicate the form. This is the slope-intercept form. All right, next we are going to graph. Let's go ahead and graph this. In order to graph the line, we just need the slope and the y-intercept. So the slope m, also known as your rate of change, is negative 3 over 2. What does that mean? We are going to have a negative rise or a fall of 3 units, and we're going to run 2 units. All right, where are we starting from? The b is 4, or your y-intercept. So let's go ahead and graph that. So let's see, positive 4. It's pretty high up, so let's move it lower. Okay, so we're gonna start from positive 4, drop 3, and run 2. So 1, 2, 3, 4. So that's 4, 3, 2, 1. Always start with your y-intercept. So the first point that defines our line is right at 4. The point 0, 4. We're gonna drop 3. Let's go ahead and do that. So drop 1, 2, 3. So drop 3. And then we're going to run 2, 1, 2. All right, that takes us to the next point right there. And then we can go ahead and draw our graph through these 2 points. And that's basically what the graph with this equation looks like. Okay, so let's label the intercepts. This point right here is your y-intercept. It's basically the point where the graph cuts the y-axis. And this point right here is your what? This is your x-intercept, where the graph cuts the x-axis. All right, let's label the axis y-x. And then the rate of change as a slope. In this case, let's put it right here. You're going down negative 3, and you're running 2 units. So this is 1, 2 right here. So this triangle, m, which is negative 3 over 2, is your rate of change, also known as the slope. All right, let's take a look at question number 3. For question 3, what if we have the following information? What if the line goes through the point negative 2, 3, negative 2, negative 3, and has a slope of 3 over 2. Okay, now in order to do this one, we're going to use another formula that reduces to the slope-intercept form. Okay, we're going to be using the point-slope form of the equation of a line. So the formula we're going to be using here is y minus y1 equals mx minus x1. When this equation is simplified, it becomes the slope-intercept form. All right, so let's go ahead and do that. Here we want to identify what x1 and y1 are. x1 is the x coordinate of the point, y1 is the y coordinate of the point. and n is 3 over 2. This is all we need to input into this formula to generate the point slope form. Okay? All right, so let's go ahead and do it. We have y minus y1, which is negative 3, equals m x minus x1, which is negative 2. Okay, now let's simplify this a little bit. We have y plus 3 equals 3 over 2 times x plus 2. Now freeze for a second. This right here is the point slope form of the equation of a line. Point slope form. Okay? But the question asked us to write the equation in slope-intercept form, all right? In order to accomplish this, we just have to get y by itself, okay? So let's go ahead and do that. Y plus 3, first thing we're going to do is distribute this 3 over 2 across these two terms in the parentheses. So that yields 3 over 2x plus, and then you can put a 1 over here, multiply, you have the 2 cancels out with that 2, so it's just 3. And then lastly, to get y isolated, you subtract 3 from both sides. And that leaves us with y equals 3 over 2x. And that is the slope-intercept form. Okay, this is the form that we're asked to find, slope-intercept form. All right, now next thing we're going to do is draw the graph of the line. Let's go ahead and draw the graph. So in order to generate the graph, we need the slope and the y-intercept. So the slope m is 3 over 2. That means we're going to rise 3 and run 2. And then the y-intercept, where you're going to begin, is actually 0. Okay, because if you have no constants added onto this piece, you just add a 0 there. Okay, that's going to be your y-intercept. Okay, let's go ahead and graph it. So you have your y-axis. Notice our y-intercept is 0, so we can put our x-axis pretty low without any problems. Okay, so starting from 0, we have to graph the first point, which is the y-intercept, 0, 0. We're going to rise 3, 1, 2, 3. All right, 3, 2, 1. And then we're going to run 1, 2. Okay. All right, so let's put the growth triangle there. So you rise 3 and run 2. Okay, that's our rate of change or slope, or m. All right, so let's go ahead and draw the line, graph the line through the given points. All right, so there goes the graph. Now we're going to label the intercepts. Since it goes through the origin, guess what? Our x and y intercepts are going to be the same. So this is our x and y intercepts. And then our rate of change, we went up 3 units and ran 2. So this growth right here, m, which is 3 over 2, is our rate of change. All right, let's take a look at the next problem. Let's say we have a line that goes through the points -3, -1, and the slope is undefined. Okay, so there's a shortcut you can use here to write down the equation of this line. And the equation is basically, the shortcut whenever you have an undefined slope is that you have a vertical line and you just extract the x coordinate, x equals -3, and that's your final answer. Okay? but we can also do it the long way. Let me show you how to do it the long way. So if you want to do it the long way, we're going to use the same formula as we used for the previous example, and that's y minus y1 equals mx minus x1. Okay, so here x1 is -3, y1 is -1, and then our slope is basically any undefined number. What makes a number undefined? Any number divided by 0 is undefined, okay? So we can, let's just say 1 over 0, that works. Okay, now we're going to plug it into this formula. We have y minus y1, which is y minus -1, equals m 1 over 0 times x minus x1. So x minus -3. All right, so if you simplify this side, you have y plus 1 equals 1 over 0 times x plus 3. Now you multiply both sides by 0. Multiply by 0, multiply by 0. All right, so here we have a multiplication. And then on the left side, this entire thing becomes 0. And then on the right side, something weird happens here. These cancel out. You're left with x plus 3. And then you subtract 3 from both sides. And then you end up with x equals -3. Okay, so this is a long way of doing it. But if you just see that the slope is undefined, though you don't have to bother doing all this. Just extract the x coordinate and set x equal to that value, and that's your final answer. On the flip side, if the slope is 0, you extract the y. Okay, undefined, extract x. 0, you extract your y. So that's the equation. Now let's go ahead and graph it. Now, what does a line with an undefined slope look like? A line with an undefined slope is a vertical line, okay? So in this case, we have a vertical line that goes through -3. So what's our y-intercept? There are no y-intercepts here, okay? Except you have x equals 0, then the y-intercept will be 0. And let's see, the slope. The slope is undefined. Okay, so example of undefined is like 1 over 0, something like that. You have rise, but there's no run. You keep rising and rising and rising. All right, so let's go ahead and go ahead and graph this. So since we have just x, we can use that as our x-intercept since y-intercept isn't helping here. So we know for a certainty that our x-intercept is going to be -3. All right, so that means I have to shift my y-axis to the right. All right, so let's go ahead and graph it. So we have -1, -2, -3. So there goes our x-intercept. We don't have any y-intercepts in this problem. To get the next point, you just rise 1 and run 0. Okay? And that gives you the graph of the line. You have a vertical line that always has the x value of -3 regardless of what your y value is. Okay, so this is your y-axis and this is your x-axis. All right, so this is your x-intercept. That's the only intercept we have. And then concerning our rate of change, we're going to be going up just 1. Okay, so our rate of change has no run or has a run of 0. So the rate of change or slope m is undefined. Okay, it's not a number, so that's our rate of change. Rate of change is undefined in this case because we have a vertical line situation. All right, let's go ahead and take a look at the last example. So for this one, Number 5, we're going through 2 given points, through -5, -1, and 0, 1. All right. So in this case, we're going to be using 2 formulas. Let's take a look at what the formulas are. We have y minus y1 equals mx minus x1. That's the point slope form of the equation of a line. But in this particular example, we need a formula for m, which is y2 minus y1 over x2 minus x1. That will help us determine n, which we will be plugging into the n component of the point slope form. Okay, so since the point slope form of the equation of a line is dependent on the slope, we're going to start off by finding the slope. So x1 is -5, y1 is -1, x2 is 0, and y2 is 1. Okay, so our slope m is y2 minus y1 divided by x2 minus x1. All right, so minus times minus is a plus, so we have 1 plus 1 over 5. So our slope in this problem is 2 over 5. All right, now we have everything that we need. We're going to plug it into this formula, y minus y1 equals mx minus x1, because we already have y1, x1, and m. All right, so we have y minus y1, which is -1, equals m x minus x1, which is -5. All right, so let's simplify this a little bit. We have y plus 1 equals 2 over 5 times x plus 5. All right, so just FYI, this is the point slope form of the equation of the line. Point slope form. But we're looking for the slope intercept form, okay? So just get y isolated. To achieve that, we distribute 2 over 5 to these two terms. So we have y plus 1 equals 2 over 5x plus 10 over 5, which is just 2. Subtract 1 from both sides. And you're left with y equals 2 over 5x plus 1. Okay, so this is the desired result, desired equation, the slope intercept form of the equation of the line, slope intercept form. Okay, so now that we have a slope intercept form, we're now going to proceed to the final part, which is to graph. Okay, now in order to graph this, we just need the slope. Slope is 2 over 5, which means we're going to be rising 2 and running 5. We're starting from the y-intercept of positive 1. Okay, so let's go ahead and do it. We have a positive y-intercept, so we can move our x-axis down a little bit. Right there. So there goes our axis, our x-axis, and our y-axis. So the y-intercept is 1. Mark that point. To find the next point, we're going to rise 2 and run 5. So 1, 2, 3, 4, 5. So that's 5, that's 2. So let's go ahead and put in our growth triangle. So we're going to start from here, rise 1, 2. All right, so rise 2, and then you run 1, 2, 3, 4, 5. That takes you to the next point that defines the line. Point there, 1 point here, and then you draw a line through the 2 points, and that's the desired line that you're expected to graph. Okay, so there goes your line. Okay, All right, let's label the intercepts and rate of change to this point of intersection right here. That's your x-intercept where the graph cuts the x-axis. And then this point right here is your y-intercept as we expect. And then we had the rise of 2 and a run of 5. So the slope, 2 over 5, is our rate of change. Do not forget, rate of change of a line is basically the slope of the line, all right? So that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study about equations of lines, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we will be more than glad to support you. Do not forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.